Hello and welcome back to Algebra. We are going to take a look at the section 5.2 for addition and subtraction of polynomials. So this is somewhat a short section because we are looking at addition and subtraction of like terms, and this is something that is used a lot. It will be definitely given it will be definitely used in every course that it's following after this one. So I'm hoping that you will pay extra attention and learn it very well. So let's start first with words, terminology that we need to know. So we start with the word term, right? That's the most important word right now. And term is going to be anything that is so term, let's say constant and or variable held together by multiplication or division. So here are the terms. So examples: 3x, 2xy, x over 6, 1/3 x squared, 2ab squared, right? So, or number 10, right? So all of these are examples of single terms. So I'll just point the arrow and I say each of these is a term. Each. So this list contains 6 different terms on that list. So if I put this term, let's say 2xy, we're going to split it and we'll call the front coefficient and the last part will be variable part. So that's what we have, right? We have coefficient in front, that's the number, and the variable part. Now if you take a look at this one, does not have a variable part, right? We can only have, let's say, x cubed, then that would not have coefficient. But as long as there is something present, right, and they're connected by multiplication and division, that means that you are talking about a single term. So now what we are going to do is we are going to say that when you connect, using addition and subtraction, when you connect many terms, you get what we call polynomial. So polynomial is collection of terms held together by addition or subtraction. Example: 3x squared plus 6x minus 9. That's an example. So in this example, so let me write it here. This polynomial has 3 terms. So this polynomial has 3 terms. Term 1, term 2, term 3. So 3 different terms. How do I know? Well, terms are separated by addition and subtraction. So since there's 1 plus and 1 minus, that means there are three terms. So each one of these individually is a term. So we have 3 terms, and now we're going to learn 3 words, but so we have a monomial, one term polynomial. So technically all of these here are monomials. You have 6 monomials there. Mono means 1. Binomial, 2 terms polynomial. Bi means 2, right? B. Trinomial, 3 terms polynomial. And we use the word polynomial for 4 terms and more. So we don't have special names. We don't have special names. We just say polynomial for anything that has more than 4 terms or more. So what do you expect in terms of the problems that contain terminology? Here, classify the polynomial. You get 3x squared plus 6 and something to write on the line. You get 4xy squared. You have to write something on the line. You get x cubed minus 6x squared plus x minus 11. You get to write something on the line. 1 minus x squared. Write something on the line. Let's do one more. Let's go one that you will see many times. Oops, plus 5x plus 6. There we go. And you get to write something on the line. So classify, right? You will go and you say, oh, I see 2 terms. Binomial. Obviously, on MyMathLab, you just pick, right, in the drop-down menu. This, all 1 term. No plus or minus signs to separate another term and so on. So monomial. One, two, three, 4. 4 terms, polynomial. Word poly means many, so polynomial. Over here, 1, 2, binomial again. And finally, 1, 2, 3, trinomial. So you will need to learn the words first, and you will need to know what they look like so that you can continue with the lecture. Once you know the names, we can start talking about addition and subtraction of polynomials. Oh, by the way, you might run into a problem. Let me do that first. you might run into a problem which asks you if something is a polynomial or not. So you will have 3x squared plus 6. You will have 1 minus 1 over x. You will have x squared plus square root of x. You can have mx plus b. You can have x to the 100 minus 7x. And 2x plus 6, everything squared. So you might run into something like this. And the question is it a polynomial? Well, the first one is easy. A definite yes, right? It's a binomial, right? Now we move to the next one, and this one says we have x in denominator. That's not allowed. Your polynomial, I am trying to avoid the notation that we use in pre-calculus, but the polynomial is only allowed to have x to the positive integer value. Now x is actually -1 exponent, so this is a no. You cannot have x's in denominators. No x's in denominator. Next one has a square root. Square root has a power of 1/2. That's not a whole number either. No. No roots allowed either. Only positive exponents. So mx plus b? Yeah. Because x is raised to the first power. M and b are just numbers, so we're all good there. 100 and the 1 on x are both positive whole numbers. So again, yes. And now we get to the one on the bottom. Now, some of you already know it is actually the next lecture where we learn multiplication of polynomials. But if you FOIL this, you will see that it works as well. I'm not sure what my MATLAB is going to throw at you in terms of the homework. So I just want to cover most of these that you are going to possibly see this semester. Now, clearly the last one, the one with the square, we are going to learn that one tomorrow in the lecture. So I will post another video tomorrow, and you guys will have that info on how to do this as well. All right, cool. Finally, we're at the point where we can add and subtract terms. So the way we add and subtract polynomial terms is we use what is called like terms. Like terms. So can I fix this? Let's rewrite. We add / subtract like terms, and that's the big word. So we need to explain. Like terms have identical variable part. It has to be absolutely the same. So, a plus a is 2a. 3x plus 6x is 9x. 8y squared minus 2y squared is 6y squared. 4xy plus 3xy equal 7xy. Actually, let's go blue. Note that variable part stays the same. So if you're understanding the line 1, apple plus apple is 2 apples. Very simple. 3 unknown quantities plus 6 unknown quantities is 9 unknown quantities. Right? There you go. Again, 8 of something minus 2 of the something that is the same is going to be 6 of that something. So if this y squared represents a flower, 8 flowers minus 2 flowers is 6 flowers. Right? If y squared represents flowers. So as long as you have the same variable part, you are allowed to add and subtract constants, coefficients in front, and you're good to go. If there is nothing written in front in terms of the number, it's obviously 1. Now, can we add 3a plus 6b? The answer is no. Cannot add. Not like terms. See, the variable part is different. One has a variable part of a, the other one has variable part to be b. Well, a plus b cannot be added into a single value. Same thing goes if you have higher exponents, if you have technically anything else. So if I go and say 4x squared plus 6y, well, cannot add. Same, not like terms. Say you have 15x squared minus 3x. Cannot subtract in this case. Right, so when you have different variable part, you cannot combine them into a single problem. Now you have to be careful, right? Because you might run into a problem which looks like you can't do anything with, but then because we learned in chapter 1 the commutative rule, you actually can. And some of you made a mistake on exam 1, right, where we learned this stuff. So here, I'll write it in blood, careful. Okay. 3xy plus 5yx is actually 8xy. The reason is xy is the same as yx. It's the commutative rule. So because this is commutative rule, 3 plus 5 is 8, right? So whether you write xy or yx, it doesn't matter. It is when you involve squares, let's say you have 3x squared y plus 5y squared x, now they're not like terms. Because this one has 2 x's and a y, and this one has 2 y's and a single x. Right? So, not like terms. There you go, explained right there. you can see that one has two x's, the other one has two y's. That's not the same. X is not the same as y. So we cannot combine those two terms because they are not like terms. So that's something to keep in mind. Okay, so now let's add polynomials. We understand addition of terms, but we need to add polynomials. So first polynomial, let's say x squared plus 3, and we want to add that to 3x squared minus x plus 1. The trick is to add like terms. So what do I have? When I get rid of these parentheses, I have x squared plus 3 plus 3x squared minus x plus 1. X squared plus 3x squared is 4x squared. Minus x and plus 4. And I am going to color code this now because I have my x squared terms and they add into a 4. Then I have my negative x here, which has no pair, so can't add to anything else. And finally, let's go with the wood paneling. There we go, this one and this one to give us 3 plus 1 is 4. So we add like terms, and the answer is 4x squared minus x plus 4. That's what you get when you combine two polynomials together. All right, another example. Let's pick something from the homework. Work the same problems that you guys are going to see. It says, problem 41, y cubed plus 3y squared minus 5, that's the first polynomial, plus, and the second polynomial, 3y cubed plus 4y minus 4. All right, we're going to remove the parentheses, and that means that every term will be multiplied by the one number that it's in front. So y cubed plus 3y squared minus 5 plus 3y cubed plus 4y minus 4. Since this is a positive value, this is assumed there is a positive value there. We do not have to change any signs. You only change signs when you have a minus sign. Well, these are all positives, therefore we don't have to change any of the signs. So y cubed plus 3y cubed, those are the like terms. Then let's go with red. 3y squared does not have a pair. 3y squared is on its own. The wood paneling for y. Y doesn't have a pair anywhere, right? That's the only term that has a single y. And finally, well, let's use black. It stands out. There we go. Constant term. So we start with the highest degree. That's going to be 4y cubed. Then we drop down to a square. Now that one does not have a pair, so it's going to go alone. Drop down to single y, again no pair. And finally minus 5 minus 4 is minus 9. And that's it. We have our polynomial. Subtraction. Again, use like terms. But first, you have to remove the parentheses and apply the negative before you do anything else. So let's say you have x squared minus 1 minus 3x squared plus 6x plus 4. We have a binomial minus trinomial, right? And we want to see what we get on the other end. Well, we must remove parentheses first. So that's going to give us x squared minus 1, right? There's a positive in front, therefore nothing changes. Now this minus sign will distribute everywhere. So this is, we get negative 3x squared, negative 6x, and negative 4. So minus sign distributed and changed all of the signs in the second parenthesis, because the minus sign right in front of the parenthesis means it applies to every single term that you have, and whatever sign they had will be flipped once we multiply it by negative 1. So that's why all three terms, right, from the second polynomial, all three terms are negative, because all of them started as a positive, right? That's positive 3x squared, that's positive 6x, that's positive 4, right? So all of those are positive values, and that's it. So now we do the like terms. We have our x squared, that's the highest exponent, that's where we start. Then we have our second term here, which would be the regular, right, x. And finally, we can go with, orange is not going to stand out, wood paneling, here we go. But this one is close to red as well. Let's use black, whatever. And then we have constants. X squared minus 3x squared, that's negative 2x squared. So that's my red, right, combined. Because you are only allowed to work with like terms. So x squared is like other x squared, which is why you can subtract them. Then we have minus 6x, because it doesn't have a partner, right? It's single. And finally, we have minus 1 minus 4, which gives us negative 5. That's the constant term. So make sure that your result, your answer, is presented in the form where the powers keep going down, right? That's something that's very important. So you list the highest power first, and then you go down the problem, and you just pick the next largest one, the next largest one, next largest one, until you get to the most simple, right, one. In this case, is a constant. So let's pick up problems for subtraction from the textbook. They love y's. I think it's problem 60. 2y squared plus 3y minus 2 minus y squared minus 2. I mean, y squared minus y. So as we discussed it already, the first order of business is to get rid of the parentheses. Since the first parenthesis has a positive sign in front, right? We don't write it, but it's positive. We just remove the parentheses and move on, right? Now the second parenthesis here has a minus, and that minus needs to distribute to both terms, right, to get rid of the parentheses. So it becomes negative y squared and it becomes positive y. So once you start multiplying by this negative to get rid of it, it will change the signs. Whatever the sign is, -1, right, will change it. So we had a positive y squared, it turned into a negative y squared, and then we had the negative y. Well, negative y times negative 1 is positive y. So all of the signs are changed. And now we go and we look for like terms. That's like totaling y squared, because 2 minus 1. Then we have the y term. So that's plus 3 plus 1 is plus 4y. And finally we have minus 2 at the end, which is constant, right? So we know what the polynomial is now. Now some of you will be looking at this and saying, why do we need to know this? Simplifying mathematical expressions allows you to work with, usually, right, allows you to work with smaller numbers. It allows you to, if you program something on a computer or so on, and you use these simplified equations, it makes sure that computer is doing the least amount of calculations to do something. And we want to have, right, while we are programming, we want to have all of the equations simplified. So you're learning how to simplify when you have two different polynomials, right? You can add or subtract them and create a new polynomial which contains features of the previous two. So they have a lot of cute problems in the textbook. I hope you will be looking at these. Let me work out a couple of more examples, especially the ones for subtraction, because you guys forget for some reason to distribute a negative, and as the whole thing goes to hell quickly. Problem 65 has ab squared minus ab squared plus a cubed b. Well, we get rid of the parentheses and we change all of the signs that we can. I mean, we change the signs when you distribute. So we distribute first. We don't need the parentheses for the ab squared. And then we have minus ab squared and minus a cubed b. These guys cancel, and you have your solution right there. Let's see what else. Let's see. Oh, we can chase these around a little bit. No, they're actually good. This is one of the basic forms. Yeah, let's take a look at it. 66 has x squared plus 3xy plus 4y squared minus x squared minus xy plus 4y squared. This pops up in later coursework very frequently, so I hope you will be able to combine like terms. But before we combine like terms, we have to, yes, get rid of the parentheses. So x squared plus 3xy plus 4y, and now this minus will distribute everywhere, so we get minus x squared plus xy minus 4y squared. Now these two cancel because x squared minus x squared is 0. So now I have 3xy and xy, so that's 4xy, because 3 plus 1, right? Oh, this is a square over here. I forgot to write a square. And now we have the y squared terms, which also cancel. And the answer is just 4xy. So you subtracted two trinomials, and your answer ended up being, in this case, right, your answer ended up being only one term, right, and 4xy. And believe it or not, that's it. That's it for 5-2. There is a little bit of terminology and front, right? Learning what each one of these means, term, polynomial, and then the names for it. And then after that, all you need to remember is to add and subtract polynomials. You have to have exactly the same variable part. And classify the polynomials, figure out whether it's polynomial or not, and then just use like terms to add and subtract. When you get to subtraction, make sure you remove the parentheses and change the signs first. And the rest of the problem then should not be a big issue. So that's it for 5.2. Tomorrow, 5.3. Bye.